Hello everyone, are you able to hear me clearly? Alright, now I have fixed my headphone. Is my voice a little clearer than the previous one? Alright, hello Vidya, hi Sandeep, hi Lux, hi Sharvana, hi Anandita, hello Josie. Alright, so do you have any questions before we start? Alright, I'm assuming there are no questions at this point. Alright, so yesterday we talked about mostly about HBase. We also talked about how to design the database schema. Along with that, I mean, not really database schema, but sort of the data model. All right. And then we talked about the API in the case of in Java. Now, as I was telling you earlier, that you can do the data churning on top of HBase using MapReduce MapReduce API provided by HBase. All right. So HBase itself provides its own MapReduce interface. Okay. So basically, you can create your mapper instead of extending the traditional mapper. You can create something called table mapper. You extend table mapper class, you define what is the output the table mapper is going to give. Because here the input is already predefined. The input to your mapper is each row, each row of the table is the input to your mapper. Okay. So as you can see that what we have done here is we have extended table mapper. We created this myMapper class, although it's not needed to make it static. All right. There's no need of making it static, but yeah. Next is that we have created these string names. I mean, we have converted CF column family name to bytes and attr1 string into bytes. And then we have also created one variable called int writable. And afterwards, once we have created these descriptions, we will be writing a map method. What it will do is it will get row as the input, okay, the full row as the input, and it will write the result into context. In case it fails, it can write the error into the result. All right. So here we are saying that string value equals to value dot this one, and then we are setting it as the output. Okay. I mean, same as the word count, and then setting it, writing it into the context. Next is that we write a reducer in the same philosophy by extending table reducer. Here the data type, input data type will be same as the output data type here, which is text and int writable, and the output given by the table reducer will be of this form. All right. and you define a method called reduce, which gets a key and a list of values and get a context object into which the reduce function can put the data. So here in context.write, it's giving null as the key while value is being given based on this particular information. Okay, what it does is it is giving the put as the output, and what put will do is it will create a row and add into a particular output table. It will put it into a output table, and that's what it's doing. All right, so it will write into a column called counts, and it will save it into the database. All right, next is that once we have created a mapper and a reducer, we can stitch it together using a driver code. This is the driver code. It will be in your main method, where we are first creating a configuration of HBase configuration object, and and creating a job. All right, creating a job, and afterwards we can optionally add few more things here. We can create a scan object. And what does it mean by creating a scan object? We can define the row range on which the MapReduce will apply, as well as optional column ranges for the scan to be for the MapReduce to be applied. Okay, so we can minimize the area of impact of MapReduce in case you, because when you are running MapReduce, it is and you have millions of columns, then you would definitely like to minimize the total data input, right? Therefore the scan object is quite useful here. And so you initiate your mapper job, you initiate table mapper job by providing the input table name, then the scan object, and the mapper class, the name of your mapper class, and the input, the output of the mapper class, the output of mapper value class, and the job object. Okay, and the job object. You have the reducer job here. All right. Similar to that, we create initiate our reducer job, and once we have done defining the job, adding these mapper and reducer job into the job object, what we can do is we can basically wait for its completion, and it will start processing. It will start executing, and the output table this target table will get the output. All right. You can try this. So the model is very much similar to what we have done earlier, just that the data input and output both are happening to HBase table. Okay, both are happening to HBase table. So here the whole mechanism of querying is not as beautiful as SQL was, but it gets the work done. It gets the very complex work done using the MapReduce job. All right. Now, next thing I want to discuss is the Bloom filters. A Bloom filter is essentially a way to minimize the querying. All right. Bloom filter is essentially needed to reduce the total query, and it's great if you are getting lot of requests in HBase for the keys that do not exist. All right. So if you are expecting a lot of querying which do not for the keys which we do not have in our HBase, then it makes sense to enable Bloom filters. All right. When people are querying your database, and statistically you have realized that the way people are querying is it mostly leads in the record not found. In those cases, a Bloom filter is very useful. You can enable Bloom filter on your HBase table. All right. So a Bloom filter is basically, how many of you are already aware of what is a Bloom filter? Anandita, Jairam, Joshil, Lux, Lloyd, Sandeep, Sanjay, Savna, and Vidya. Are you aware of what is a Bloom filter? All right. All right. So looks like none of you are aware. Yeah. So the main reason why I have included Bloom filter in this, even though as a concept with respect to HBase, it is just required partially. It is just required partially. It's not something, you know, must have in case of HBase. But it is very important to learn about Bloom filter because when it comes to big data, Bloom filter is a great concept. All right. So if you have a database in which on every query it looks into the disk and then responds to you. Okay. On every query, wherever you are saying that get me the record where ID equals to this. If it's looking up into the system now and then or at any point of time, then the two, the querying in the disk might take a lot of time, and and so some of the researchers realized that their databases were getting a lot of false queries, as in lot of queries for which the record did not exist. Okay. Basically, a record not found kind of queries were coming a lot. Me, or let me try to put it in another way. So, in the situations where you notice that a database is getting lot of queries for the records or record IDs which do not exist in the database, what happens is that the database unnecessarily work on those. And this kind of scenario is well optimized using by enabling a Bloom filter. All right. So Bloom filter is a general concept in computer science in which you basically maintain a smaller list into the memory. Okay. And such that when the user looks into the list, you can confidently say no, but you cannot confidently say yes. All right, let me come again. Let me try to give you a better example. Let's say you have a database table of 20 billion records, 20 billion names of people. All right, let's say, all right, let me just save these records because if computer shuts down, it becomes a big problem. What is the date today? All right. All right. So coming back, let us say Let us say you have a table having 10 billion records. Okay, 10 billion records, and people keep on querying, is the font visible? And people keep on querying all the time. Okay, so for each query it will of course have to either make a disk lookup, or will have to make a network call, right? Because the data will be in the disk. So what you do in these kind of cases is you create something called um, all the time for names which don't exist. Okay, so to optimize this, what people found out that, let's create another list called bloom filter bloom filter, in which we will store we will store only the hash code of the name. Okay, or in other words, let's just try to simplify our hash code. Let's say we just keep a list with first four letters of a word. So if we just create a list of first four letters of each name in this, each each of of name from each row. Okay, because we are getting lookups on, so the problem statement is clear. We are having a table with 10 billion records, and each record contains one field called name of the people, on which people are looking again and again. now Now, in this case, when people are looking again and again on the name, and you realize based on the past history that a lot of times, say 90% of the time, people are looking for the name and we don't have that in these 10 billion records. So in such case, you will realize that Bloom filter is a great opportunity. And what Bloom filter does is it creates another list, okay, list of records, which is very small in nature and which can be maintained in the memory. Okay, so, and this list is prepared either by doing some sort of hashing of the name. And if you remember, the way we always prepared hash was to convert a big string into a small number, and therefore it could, one hash code might mean multiple actual names, right? In the same way, let's say our hash code is just picking up first four letters of the word. All right, so when the query for the first time comes in, it would go to the filter and say, for example, the user is asking for key 1. User is asking that, do you have key 1? And filter will say, okay, I don't have this. Filter will quickly compute the hash code of key 1 and find that if it exists in our list. Okay, if the hash code doesn't match, it is definitely no, because no matter how many hash codes are existing for, so there can be only one hash code for a string, but there could be multiple strings for which there could be a single hash code. Agree with that? Multiple strings could have a single hash code, but a string will always lead to the same hash code. It's a many to one relationship. It cannot be that if you hash the string twice, if you hash a string at two different times, it would result in different hash code. It will always result in the same hash code. Okay, so if the hash code of a key is not found in the filter, that means it is definitely not there. The actual record is not there at all. Therefore, Bloom filter can confidently say no. But there could be two more scenarios in which first is that the user came and we found that it is there in the Bloom filter. The hash code exists in the Bloom filter. If Bloom filter says yes, I have this hash code of this key, then the request actually goes to the disk or the storage, and the response goes back to the user. Okay, now it will be the storage which will take the call. In case Bloom filter says yes, then the actual call goes to the disk, and then the data is compared, and the query is answered. So it's like having a proxy who answers your calls only in case of only in certain circumstances. When our proxy is not able to take a call, if the request reaches us. Or when I say us means storage here. So Bloom filter is more like a proxy for HBase actual storage lookup to speed up the process of querying. In case it's no, so the overall time is improved really high. Was I able to answer you? No. So if you have a let me try to give you a better example. So if we are taking only first four letters of each row, how many total such words are possible at max? First four letters only. Out of 10 billions, if we just take first four letters, how many such unique words are possible? Anyone? All right. So each letter can be of 26. Okay, Anandita. And 4 into, so at each place can be filled with 26 into 26 into 26. And which is how much? Let me use my Python for this. So it's hardly half a million records. Okay, it's hardly half a million records, which is how much? If each string is only 4 letter long, that means it can be easily handled by a integer. Okay, by not an integer, but hardly, you can say, hardly 1 byte, hardly 1 megabyte. Okay, hardly maybe 10 megabyte in the worst case scenario. So it can be easily loaded. These first four letters of 10 billion records, only first four letters can be easily loaded into the memory, and therefore we can very quickly look up in the Bloom filter and say no immediately. But for yes, there will be a storage lookup. All right. So now Sanjay's point is that Bloom filter is like an index of hash code for actual data. Perfectly, yes. Okay, very well put. Thank you. So Bloom filter is like an index of hash code, and hash code is a sort of minified version of your actual text. Okay. Your actual test, multiple actual text can lead to the same hash code. Okay, and hash code could be as simple as summation of all the letters, ASCII code, and you do a percentage as in reminder by some value. Okay, so Bloom filter is like the index of hash codes of actual data. So Sarvana's question is, storage means HDFS? Yes, the H file. All right. Is the concept of Bloom filter clear? It's like earlier, whenever you look up for something in the HBase, it will go and try to find in HDFS and give a response. Okay. But in case you put a Bloom filter, the first lookup goes to the Bloom filter and then goes to the storage. And at every insert in storage, filter will be updated. Just like an index is updated on the table, in the same manner, the filter will be updated as in when we are inserting records into storage. So filter is like index of hash codes or index, a very small index in order to decide no quickly. All right, I think I've answered Sanjay's question now. Okay, at every insert. In which server a filter is maintained? Generally in HBase master actually. Okay, now Lloyd's question is there any overhead on the system? Yes, because at every insert you have to update the you have to update the Bloom filter data. Okay, also in case of a hash code is found, okay, as you can see here, in case of false positive there is a unnecessary disk access. Okay, in case of false positive there is unnecessary disk access. All right, great. But all of these things are well covered by the benefit you get in case of filter. All right, now the Bloom filter can be enabled per column family. Okay, or and if you are enabling Bloom filter for per column family, you can have three modes. You can use an API called H column descriptor and set Bloom filter type, either none, row, or row call. If you are saying none, that means this table will not have the Bloom filter. If you say row, that means the hash of the row will be added to the Bloom on each insert. If there is a row call, as in the hash of row key, column family and column family qualifier will be added to the bottom of each key insert. It all depends on how do you want to query. All right. You can see the more details here in a Quora question. This answer is written by the author of Bloom filter in HBase, and both guys who implemented Bloom filter in HBase has written an answer on Quora, and also you can have a look at the manuals if you are looking for more details, right? Now, if you there is an idea called coprocessor. Now, there's a question from Sanjay Tandon. Can we set multiple Bloom filter for multiple column in column family? So, because you can define the Bloom filter only per column family. That means you can define as many Bloom filters as column families you have. Okay, if you have three column families, you can define it on only three column families. There could be only three Bloom filters. All right, that was a question from Sanjay. One for each column family. All right, great. Moving ahead. Now, in the beginning, I talked about something called coprocessor. I'm hoping that you are aware about a database trigger. How many of you are aware about a trigger in database? Lloyd is aware. Okay. Sandeep is aware. Sanjay is not. Sarvana is not. Okay. All right. All right. Okay. So let me just recap what is a trigger. So a trigger is basically some logic or inside we create some kind of function or stored procedures which we create on the database side which handle various kinds of event. Okay, let's say on the server side you are creating a trigger on a table insert. If you are inserting a row into a table, this particular logic will get executed. Similarly, you could hook a trigger to table being column being in added or schema being modified. So for all of these kinds of events, you could create the triggers. Okay, trigger is basically a PL/SQL kind of a logic in which you can handle various kinds of database events. All right. So in the similar manner, you have coprocessors in HBase. At various times, you want to customize the behavior of HBase according to your business need. For example, you want to restrict certain people from access an HBase table. You want to give an error if a certain class of user is trying to access a certain table. Okay, or when people are trying to get the data, you want to do some sort of operation, either insert, update, delete, get. For all kinds of operations, you can do some sort of server side code which will be run when a certain action happen in the database. Okay, this is like sleeping logic on the database side. Whenever some event happens, this logic awakes and is consulted or is executed on the HBase side, either in the region server or in the HBase master at any of the places. All right, so when you have to create coprocessor, all you have to do is handle pre-XXX kind of event. It's a sample class. It utilizes reason observer and it's basically doing an access control, an intercept pre-XXX event, pre-get or pre-put or pre-delete kind of event to check whether the user is privileged for that given table and column family. Okay, so let's say we are creating our class called access control coprocessor, which has to extend mandatorily this particular this this particular class. All right. So it has to extend this particular class, and then it has to override this. This is probably the important logic. Pre-get, for example, you give a coprocessor, so you will be given the coprocessor environment as in the configuration and the get method details, and then you can say easily that okay, this get will also have information like which column the user is trying to get, and you can check the permission and either throw error, throw exception, or you just let it go by returning the get as such. Or you could do the modification to get object by creating a fresh new get object. Therefore, you can alter the data before the user accesses it. You can do various kinds of beautifications at this point. Before returning the data to the end user, you could create a fresh new get object and give it, make some alterations and give it to the end user. All right. Now, this will get executed on the reason at every region wherever the data access or data creation is happening. In the similar manner, you could also control pre-put and pre-delete. All right. You could also control pre-put and post pre-put and pre-delete, as well as there are methods which you can override here called post-get and post-put and post-delete. All right. So this way you can put tab on every event that happen in your database. All right. Now once you have created this class, there are two ways to deploy it. Okay. One is copy this to every region server and add it to the HBase config on every region server inside HBase site.xml. You add a property called hbase.coprocessor_region.class. You add your name of the classes which you are extending. Okay, like this. We have just added our two classes comma separated way in this property. All right. Or there is another way to it by marking it in the table value. You could create one. You could basically mark it in the properties of the table in the HBase itself. If you add a particular column in the if you add a particular column in the HBase with the name called coprocessor $1 and the value as the actual class name along with the actual full class name, then that will be executed by itself. Also here you can create a path which can be given to the server. Right? You can have a look here how it's being used. Alright. So whatever class you want to load, you can basically put that into into the table itself, and HBase will pick this data from the HBase table itself. Instead of you having to modify all the region servers, the HBase will inform all the region servers about this class. Right? Now, when it comes to the REST interface is what? It does not require any special client. Okay, you give a call to URL with all the information about the things you want in a kind of stateful URL where everything is mentioned in the URL itself rather than as part of header, footer, or any other way. Okay, so you can simply make a call on HBase and you can simply make a call to HBase from any of the www clients. Okay, be it wget, be it curl, or be it any HTTP client, you can make a call to the REST interface from HTTP client easily. So to do that, to be able to access the HBase API, you need to start HBase daemon, which will be running continuously and listening on a particular port. Or you could say things like this: HBase REST start at port this particular one. All right, let's try to start if it works or not. All right, so we are on here. So you can see that it is trying to start HBase at this particular port. So it has started the port at 0000. Okay, 00 is IP that identifies all the interface, all the network interface on the machine. Had it been 127.0.0.1, that means you are just trying to access. This is running only for the users who are on the local host, not for the World Wide Web. Now let's go to Hadoop one and try to go to, let's say, this particular. All right. Now there was one more thing which we were trying earlier. What was that port number? Can somebody help me out? I think it was 4040. Was it 4040? No. What was the port number which we were using yesterday to access our HBase? I completely forgot. I completely forgot. Yeah, this is the one, right? Yeah. So if you can see that when I said 1111, it has given us the list of all the databases. And if we go into one of the tables, let's see what happens. It says the method is not allowed. All right. Let's have a look at it again. So, all right. So you can make a call to something like this: my table slash row ID and then the column number. Okay. You could make a call to this. Zero or more than one column specified. All right. What were the column names which we created? CF1 and then column one. All right. Let's just run the HBase parallelly and have a look at. You can send a running process into background by pressing Ctrl Z and typing BG HBase shell, and we say scan, or we say describe. What was the table name? My table. Okay, so you can see that the Bloom filter is per row, okay, on the row ID only, and the name is here. All right, what let's say scan my table. You can see there are these row 1 and my column family, let's say this one. Okay, if you go here, now where was the URL? Yep, my table row 1, and we give our column name. Then it gives us the data in this format. You see 5 6 7 8. 5, 6, 7, 8. All right. So we were able to access the tables from the URL. All right. Thank you, Anandita, for the port number. All right. So this is how you could access HBase over the REST interface. All right. So anything you want to automate, if you want to insert data in bulk, you can do from the REST interface easily. Okay. And this REST interface is known as Stargate, and you can have a look at Stargate at the Wikipedia. Also, if you are looking for a JDBC kind of interface, please have a look at phoenix.apache.org, which internal, when you say insert into this table or something like that using Phoenix, it internally converts that into GET put requests. So you don't have to fiddle with low-level API. You could start talking to HBase using SQL. All right, that's the purpose of Phoenix. That's pretty much about HBase. Do you have any questions for me? All right. So should we move ahead to Zookeeper? All right. So here is a tough question from Lux. Can we use HBase for transaction systems? Yes and no. So if you are okay with row level transaction, then you can. Otherwise, no. If at one point of time you are just modifying one row, okay, that means it is good enough to be. I mean, if you are just modifying one row and what you want is, as you insert more and more data into it in a row, all of the insertion, updation or deletion of a particular row can be atomic or can have transaction. Either all happens or nothing happens. So that kind of model you can build on a row level, but not on multiple rows, not on multiple tables. And okay, so if that is the case, then it's okay. All right. Now his further question is like a product catalog. Again, yes and no. I'll give you a good example. So probably the biggest NoSQL which we had at Amazon is called Sable. Okay, it's called Sable. Now, basically, the NoSQL. What was the name of NoSQL at Amazon? It was Dynamo, right? So that Dynamo is now called Sable after it has become a complete uh, system like HBase. It has coprocessors, it has all full row kind of mechanism. It's no longer a key value pair. All right, it's more like HBase now. So Dynamo has been converted into Sable. Although we had been using Sable for everything, it has taken us some time to move our catalog to Sable now, after a lots and lots of debate. So product catalog can be kept in Sable comfortably, but what could not be kept in Sable or in HBase, you cannot keep a money transactions because it's not really great when it comes to referential integrities, because when it comes to money, you generally have these strong referential integrities to track the double accounting system, to track multiple relations with the money. Therefore, for with respect to financial data, HBase will still be we will still use it rarely. The only reason we are using we are still using Oracle at Amazon for financial data, okay, for the transactions, for the actual transactions. When people pay money, that information goes into Oracle. Reason being that the total amount of transaction, amount of purchase are far less than our general transactions, as in number of people visiting Amazon.com every day. That's very high as compared to the actual transaction. Therefore, keeping a financial data in Oracle made sense, while almost every data has been moved to, including the catalog, has been moved to NoSQL. So this is my point. So if your product catalog is really huge, then it makes sense to put it in HBase. Otherwise, you can keep some data in HBase, some data in a traditional relational database. Very good question. How about data warehouse Dartmouth for HBase? Yes. So you can use it in data warehouse. As a matter of fact, you could use HDFS as well. Okay, partly because in case of HDFS, you and using Hive, you generally query the data which is maintained and which is not changing too often. All right, did I make sense, Lux and Sanjay? Was I able to answer your questions? Great. Let's move on. Brilliant questions and great. All right, should we start Zookeeper now? All right, let's start. All right. So Zookeeper is very similar to HBase, MongoDB. We will talk about it. It's a very interesting system, and why I have included Zookeeper purposefully is so that you get to know something called Paxos algorithm. When it comes to distributed computing, there are few concepts which matter a lot. Okay, and we will go into those details today. So I will focus on the elections. I will focus on the Paxos in this. All right. I'll not be going into much detail into actual what are the commands and the things, but we will go into the details about the philosophy of the Zookeeper, the architecture of Zookeeper. All right. Now let's start. Now, question to all of you. Are you with me? The question to all of you is: let's say you want to build a brilliant email processor. And what does this processor do? Imagine that this processor just indexes the inbox of people. As in when email comes into inbox, it this processor is picking the emails, trying to clean the data, and then indexing it. Or this email processor might be doing many other useful activities. All right. Now you realize that the processing of a person's email requires multiple machines to do that. Okay, let's say processing of each email takes time and you want to get it done very quickly. So what you plan is you will use multiple machines to process one email box. Now how would you Or let's say all these email boxes are stored on a single system, and you want to connect to this system continuously from morning since till evening and process these emails. Now you cannot make modifications to the inbox. You do not have write permission on inbox. Therefore, you cannot modify email IDs. Now, problem statement is, how would you make sure that no two email processors are trying to process same email? How would you make sure that two email processors are not trying to process the same email? They are processing different email. Otherwise, having two email processors purpose gets defeated. Okay, so let's say you have multiple machines. These are multiple machines, not multiple threads. All right, so you have got multiple machines, and these machines are trying to read emails from your inbox. Sanjay says need a traffic cop. Lux says maybe a range. Okay, okay, go ahead. How would you make sure that we define the range upfront? You will say that all the emails that are starting with A to X go to the first email processor, and similar in the second email processor. But that mechanism's problem is that one of the email processors will be highly busy while other email processors will be sitting idle. All right. So how would you get it done right now? Mind it, you cannot, because these are different machines, right? And you cannot use you could use thread if it could have been on the same machine, but these are different machines. Threads will not solve the problem. Anyone? Ravikant is also saying we can define range based on time of the mail arrival. Okay, okay, that's interesting approach. So based on the time arrival. Again, if you put it on the time arrival, one email processor might be busy, will get busy now, while other two are sitting idle. Because you are saying that whenever the number is divisible, if you divide the number of hour by 3, okay, or number of minutes divide by 3, if the remainder is 1, send it to first processor. If remainder is 2, send it to second processor. If remainder is 0, send it to the third processor. Right? That's what you are trying to say. Also, I forgot to give you one more hint. Each email has got unique ID. Lloyd is saying each email processor could put a lock on email it picked up. But as I told you, this inbox is read only. You cannot put a lock. Now, can you utilize this information that email has got an ID, a unique ID? Okay. So Ravikant's point was we can define the range based on the timestamp. All right, that's a good way. So again, you will make that will generally lead to a situation where one of the email processor is sitting idle. Mostly when we divide the work, that's what happens. Anybody? So each email ID has got a unique identifier. And also note that whatever logic you write, the same logic will be deployed on each email processor. Exact same logic will be deployed on all the email processors. Now there is a this is the approach from Lloyd. Hash and put it in the memory. Hash will contain the email processor and unique ID of the email. Good. The next is from Lux, that store the ID of the processor that's going to read. Good. And let email processor check at every one. Good. Very good. All right. So Lloyd's answer and Lux answer is almost nearby. So here Lux is saying that store the ID that processor is going to read in a common place. Perfect. And then let each processor check before the next. Now question to you is, Lux, question to you is, what is this common place we are talking about? Is it a file system? Is it MySQL? Is it what is it? Is it a memcached? What is it that we are talking about here? What do you suggest? Memcached. Brilliant. Okay, let me say memcached. Perfect. So this solution is what we generally do as a matter of architecture. All right. We will go into the details a little bit more. Now there were more answers. Let me try to read it for you. Savna is saying put a system to store identifier which are processed, and before reading compare it. Brilliant, just brilliant. Same as Lux. Lloyd is saying not memory. We can instead of he's further going ahead with making his architecture a little more stable, that instead of memory we could keep the data in at a central source where all email processors are stored. Brilliant. All right. Sanjay says master slave architecture, meaning what he suggests is that we can convert email processors into master slave. Probably this is what he is trying to say. And then they can talk to each other, all so to avoid the confusion amongst email processors. Is it? All right. So out of these email processors, Sanjay, do you want to make one of them as master and others two as slaves, and then accordingly communicate between them? Brilliant. This is brilliant. All right. All right. You will understand why I'm calling brilliant, because at the end of day, Zookeeper is exactly having a similar architecture. All right. Great. So we reached to a conclusion in this discussion that in such kind of scenarios where, and this is very common, that when you are processing emails or you are processing file systems, there are these automatically scalable systems. These are called elastic systems. So this is how it happens. So we will keep on increasing these email processors as and when the load increases. And half of the world runs like this. So even the system which I built at Amazon, it was infinitely scalable because you could add the same code on one more machine and start it automatically. Okay, that's how we planned it. So as and when the load was increasing, automatically the number of machines were increasing and there was no human intervention involved. Similarly here, and these systems are read-only systems because they are doing all sorts of magic. Maybe they are doing really, really difficult machine learning, or doing all kinds of magic. But all of these systems require a central agency for their coordination, a place where they can set the flags, place where they can show the indicator to go ahead to other people. a place where they can put that don't process this particular record kind of information. All right. So no matter what kind of system you're building, for parallel processing, for distributed computing, you would require a way to coordinate between them. All right. You would require a way to coordinate between them. And whatever you build to do the coordination itself has to be really, really reliable service. And that reliable service is Zookeeper in our case. Sounds great. All right. All right. So this email processor for doing such kind of thing will have to put email ID, timestamp, subject line kind of thing as an ID and put it in a box so that every email processor either would write to it or will skip it. And that's how these email processors will be talking, communicating with each other. Rather than one email processor trying to talk to other email processors, they are using a central whiteboard. This is a central whiteboard, and this is the role played by Zookeeper. All right. So what is a Zookeeper? It's a distributed coordination service for distributed application. Now there are too many distributed in this statement. So here in this example, our email processor was distributed, as in it's being run on thousands of machines. Okay. Now this whiteboard or this database, whatever you want to call it, if it needs to be accessed by thousands of users parallelly, it has to be really powerful, and such kind of power when you have to handle that many requests per second. Okay, and you have to give a really great reliability in case if it's running on a single machine and that single machine goes down, then this whiteboard is of no use and all of these email processors will be of no use. So all of these machines will go waste if your Zookeeper is not able to handle the load and 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 process that amount of data. All right, therefore Zookeeper itself is always runs on multiple machines at the same time. All right. So Zookeeper itself is a database, just like MongoDB and HBase. It's actually very much similar to MongoDB. The only difference between Zookeeper and other databases, in case of Zookeeper, we assume that the data will be very small. So it is okay to copy the data on hundreds of machines at the same time. All right. So a Zookeeper exposes a very simple primitives like get and put. All right. So that all the machines who need the coordination, they can simply get and put. I mean, instead of get and put, it basically gives a files and folder kind of a structure. Okay, it gives you a folder kind of a structure in which you could store the database. It actually looks like a file system. It's a huge tree of nodes where each node has other nodes and so on. Right? It's very easy to program to. It uses a data model like directory tree, used for synchronization or configuration manager, and it does not suffer from race conditions or deadlocks. So who can explain what is race condition and how does it differ from deadlocks? Anybody? Yeah. A race condition is go ahead, somebody. Lloyd, Sanjay, Sarvna, Ravikant, Anandita, Josie, Jairam, Kanaga, Mike, Richard, Sandeep. Go ahead, please. All right. Looks like you are not much aware about race conditions. So race condition occurs when two threads or two processes are trying to compete for the same resource. Okay? It's like having a bank account and opening two browsers to do the modification to the bank account parallelly at the same time. Booking a ticket, multiple users are trying to book the ticket at the same time. That's a race condition. If that is not handled properly, two people could book the same ticket or none of them could book the same ticket. That is race condition. In race condition results in corruption of data. Okay? Race condition results in illogical things. Race condition results in corruption of data. While deadlock means A resource is waiting for A resource is waiting for B, B is waiting for C, and C is waiting again for A. Okay? That's what we do on the traffic lights, as in everybody trying to get ahead and they block each other. So that is deadlock. So if you have a transaction is waiting for somebody to commit the transaction, and that somebody is again waiting for you to commit the transaction, and that's how you end up with deadlocks. So deadlock generally do not corrupt the data but hit your database so badly that the whole system freezes. Okay, although nowadays database has started killing all the deadlock processes, okay, to resolve the deadlock, but still it's not a nice thing to have. While in race conditions are really big horror if two two processes try to access the same row at the same time and both are able to access it at the same time and are also able to write. They might end up corrupting the whole data. Yes, Kanaga. Both require synchronization to avoid it. All right. Now, Sanjay says that contention in database language, correct? And Lloyd is saying deadlock is when two processes try to conflict access on the same resource. In that case, one process is terminated based on deadlock priority. Good, great. Now, these were the design goals of Zookeeper. These are very important. So, it's a shared hierarchical namespace which looks like a file system. It has got data nodes called Z nodes, which look like which you can think of files or directory. The only difference between this and file system is in case of file system there are two kinds of nodes. Okay, one node is called directory, other kind of node is called file. Files are leaves. File do not have children in case of normal file system. Here there is no different, there is no two different kind of nodes. Here everything is a Z node. Z node can have other Z node. Z node can have the data. You can store data in a Z node or Z node, whatever you want to call it. And this Z node, every Z node can have the further G nodes as the children. And most of the data is available in memory, and although the data is first saved in the disk, but the whole data is available in the memory. And that's the reason, since the data is available in the memory on all the machines at the same time, which means the data has to be really small. Okay, it achieves high throughput number and low latency number, and it's really high performance. Okay, used in large distributed system. The fact that HDFS uses zookeeper to keep a track of which all data nodes are available or up. There is no single point of failure. There is no, so this is the only system which we will study where the master slave kind of architecture is not there. Is the truly democratic system. The master selection is done by the system itself, and it provides the synchronization by providing strictly ordered access. All right. Now, let's understand how is it highly available. First was, it was very simple. It is designed to be really, really simple. Second design goal of Zookeeper is highly available or replicated. All right. Now, the client keeps a TCP connection to the Zookeeper service. This diagram properly shows you few things. Okay. The diagram shows you that there are multiple Zookeeper servers running Zookeeper service, and one of them is the master. Okay. And the clients are accessing this full service. They have the name of all these servers, and they keep on being redirected across the network. So you can see there are few arrows which show that the request has been redirected to the master. All right. Now the client to Zookeeper service, client, everybody is a client, okay, to Zookeeper service. Here you can see all the email processors are client to the Zookeeper service. Similarly, in case of HDFS, name node is a client to the Zookeeper service, and data node is also the client to Zookeeper service. All right. So the client gets the watch events, it sends the heartbeats to the service. If the connection breaks from the client, the zookeeper assumes that the client is dead. Okay? If the connection is not reconnected, but the client would connect automatically or quickly to another zookeeper service. Alright? These servers know each other, keep in-memory image of the whole state, as well as they keep the transaction log, and snapshots are persistent. Okay, so in case any of the server dies, they can recover very quickly. Third is ordered. Zookeeper stamps each of the requests with a unique number, and this unique number reflects the number of transactions, and this number helps Zookeeper internally design synchronization. It is really fast. The fourth design goal was to be really fast, and at Yahoo it was benchmarked for 10,000 operation per second for write dominant workload generated by hundreds of clients. Okay, now a quick test, you can see if the Zookeeper is running or not. All right, let me just kill it. All right, so a quick way to check whether it's running or not, let's check. It says I am okay. We said are you okay? It says I am okay, right? We could also check the configuration by sending conf object. Again, those who are not echo echo conf and see localhost and 2181. All right. So it shows you the full configuration. And what exactly is happening? We are saying echo conf and then piping this data which is spitted out by echo to NC. Okay, and what is NC? NC will basically connect to localhost at this port and feed whatever it gets. So this conf string is being fed to this service which is running on 2181 port on localhost. Okay, there are these other services admin kind of status to just check what's going on. All right. So Sanjay's question is, are these servers always on in sync at all the time, even though one is a master? You will understand this architecture quickly. I'll not comment on this right now. To install it, you can download the releases and you can unzip it and start it. Although you will have to install on multiple machine, installing it on a distributed way is very difficult. I mean, not very difficult per se, but it's, it requires more involvement. All right. So the data model is basically a Z node kind of one. It starts with slash. This is the top level Z node which exists by default. Then you can create one node and put data in it other than the node name. And then you could create multiple nodes under zoo. Also, please note that you cannot create another node with the same name as zoo, or you cannot create one more node here with the name goat or duck or cow, because the name, like in file system, name is unique. Name is very unique. All right. Also, please note the differences, that this path is not equal and there are no append operation. Either you change the whole data or nothing. Similarly, read and write access both are atomic. Either you read the whole or you get error. Alright, now going ahead with the Z node kind of notation. So when we create Z node, we could create multiple kinds of Z nodes or Z nodes. One is called persistent, that's the default way. We created a node, it will remain there forever. You could delete it if you wish to, but it will not disappear by itself. So those are called persistent node. Now there is something called ephemeral node. Ephemeral node gets deleted by zookeeper if the creator has disappeared. If if you connected to zookeeper and created a Z node, and if your connection breaks after around a minute, this particular node will disappear. That's the property of ephemeral node. All right. So when you connect to zookeeper, if you say that okay, I want to create an ephemeral node, these nodes will disappear. An ephemeral node cannot have children, even though if you are try to create an ephemeral children, they cannot have children. All right. Although these ephemeral nodes are tied to the client session but are visible to all others as well, based on the access control list. The third one is a sequential node. A sequential node is a node which has a sequence number automatically generated. So you provide a prefix. Unlike in other nodes, in persistent, in previous two kinds of node, persistent or ephemeral, you provide the full name of the node. Here, when you're trying to create a sequential node, the name of the node is automatically generated and appended to the prefix you provide. You can provide an empty prefix. All right. So let me try to quickly show you how to create these nodes. I'll just navigate, I'll take you through Zookeeper. All right, Zookeeper client. So I'm connected. Let's check the status. What is the, all right. Now let's try to see what are the various nodes available in the cluster. So you can see that there are so many nodes available in the cluster. All right, including HBase unsecure. So if you want to see what is there in HBase, you will be surprised to know that HBase is actually talking to each other based on this structure. Let's say you want to find out how many region servers are running currently. Okay, so you could go into this folder and it is saying that is it not this one, recovering meta region server, backup master, table, draining region in transition, and table lock and RS. These are okay. So you can see that it shows us that these are the region servers. Okay. If you kill one of the region servers, this entry will disappear. Okay. And all right. So it shows you the status of this particular. Okay. These are the various nodes created in this. All right. So you can see that it's an ephemeral node because there is an ephemeral owner. So this node, which is for each IP address of the region server, will disappear as soon as this connection from the region server breaks. And that's how it maintains the list of alive region servers. All right. Now let's try to show you. Let's try to create one node for this particular class. Let's say 29 August is what we want to create. It says you have to provide data along with this. Let's say the data is Hadoop class. All right, let's say the data is Hadoop class. So you can see now when you say ls, you will see this 29 August somewhere. Do you see? Here it is. Okay. Now, all of you can create as you are connected to this. All of you, if you create your own ephemeral node under this, after this session, as soon as you disconnect from the server, your nodes will disappear. Okay. So let's say I want all of you to give the attendance. You can give the attendance by creating a node under 29 August. Okay, let's say we are trying to create a node under 29 August. So we can say 29 August and we could say SEQ, okay, with some data called sequential data. All right, so we have created this one node. Okay, now let's say under the sequential folder we want to create, or under the sequential node we want to create something called ephemeral node. Okay, we give the ephemeral node's name. This is my, or let's say here, my EPH. This is the name of the ephemeral node. I'm sorry, I did not provide the data, so that's why it just disconnected. All right, so let's say I put some data here. All right, so it has created my ephemeral node. All right, now to create a sequential node, we could do create minus s, and I could provide the that particular node. All right, and here if I provide say v, okay, so the node that will get created will have 000 appended to it. Okay, so every time I'm creating a sequential node under a particular node, the number is increasing monotonically. Okay, you can see that. All right, the number is increasing monotonically even if the prefix is changing. So every z node has a running number. Every z node is like a register which is having its own running ID or running number right now. Okay, and you can think about it. So you could create the systems like a ticket tracking system or request tracking system, or various kinds of ID systems utilizing this property, utilizing the sequential node. All right, if you create a fresh node under a node, let's say we are trying to create a node under directly 29 August. There, since there was already some nodes under 29 August, you will see there were two nodes already, sequential and ephemeral, therefore it got 2. This is 0, 1 and 2. Alright, that's how the sequential node works. This number identifies that we are trying to create that ID afterwards. So if we delete it, if we delete this particular node, okay, and create another one, all right, it will be 3, not 2. The number is not reused. It keeps on increasing monotonically. That's the property of a sequential node. All right. Now Ravikant's question is, what are the scenarios when we create different types of node? So one is typical, the persistent node. The usual one is clear for configuration and etc. Ephemeral node to mark the presence, because to mark the presence or liveness. Okay, so as soon as the client disconnect, ephemeral node disconnect, and therefore it makes sense to create ephemeral node if we are trying to create, if we are trying to maintain who all are connected to the system, right? And sequential node in case you want some ID generation mechanism. Sequential ID generation mechanism. Make sense to you? All right. All right. Let's take a break at this point and we will talk about more after the break. All right. So, break and back by 10:17 p.m. IST. All right. All right. So let's start. Uh, is everybody back? All right. Savna, there is your question related to the UDF. Could you just email me? I'll try to respond it tomorrow. All right. I'll try to respond it tomorrow. Your question is related to the pig. All right. All right. There is a question from Sanjay. His question is valid. His question is that I'm confused on Zookeeper's relation to HDFS and HBase. Like, where does it fit in overall picture? All right. So there is one use case we just discussed. That use case was when lots of email processors had to coordinate with each other. They used a service like Zookeeper. Similarly, when HBase has to discover how many region servers are there alive, it will look into this particular directory called slash, what was the directory which we had? It was ls slash hbase and then rs. So hbase master will just talk to Zookeeper and try to discover how many region servers are there. So to find out about its region servers, HBase only need to know about Zookeeper. Similarly, to give its attendance, to give the attendance, to give the attendance, each of the region servers will just talk to Zookeeper and create an ephemeral node under this folder with their IP address. Okay, you see the IP address and there is a timestamp at which it came alive. All right. So basically, HBase master is using, or HBase is using Zookeeper so that HBase master can discover the region servers. If we had to add more region servers, all we have to do is start a new region server and tell that region server about Zookeeper, and it will create an ephemeral node here with this IP address, and HBase master would notice it by querying the Zookeeper and then distribute the data. All right. So, so HBase, uh, the discovery or disappearance of various region servers is monitored by HBase master using Zookeeper. Okay. Similarly, the in case of HDFS, we earlier talked the selection between secondary name node or primary name node is based on the Zookeeper. Okay, so basically, how will data node come to know about whether to use secondary name node or primary name node? Okay, that decision, that selection happens through Zookeeper. Every data node or every client will basically ask Zookeeper that who is available right now. Okay, because if both the connections are there from secondary name node and primary name node, there will be ephemeral nodes representing both of them. Okay, so secondary name node and primary name node will create their ephemeral nodes inside Zookeeper to mark their attendance, and as soon as any of them is disconnected, that will disappear from HBase, and and hence automatically the various data nodes and various other clients will figure out which one is available right now. Okay, so the way HBase master was trying to discover its region servers, in the similar fashion data nodes or any clients are discovering whether to use primary name node or secondary name node, okay, or backup name node, whatever you want to call them. All right. Yes. So Sanjay's point is that makes sense now, and Zookeeper is more like a gatekeeper. Yes, Zookeeper is more like a big, something like an attendance register or something like a big whiteboard on which everybody is writing about their attendance. All right. Now, when we are creating the node, we could use an operation called create. We can delete a node. We can check whether a particular node exists or not. We can also do something called access control list. Right now, in the Zookeeper, we do not have ACL enabled right now, but we can enable the ACL. Now get the children, get the data, set the data, and synchronize the client's view of a JAD node with Zookeeper. Okay. Now, all these actions we talked about just now, whether creating a node, deleting a node, checking the node, all of these actions could be, or multiple of such actions could be batched together into a single transaction. So either all of these actions would happen or nothing would happen. We can, under a transaction or under a multi update, we can have things like create a node, create a child node of that particular node, and create one more node, delete particular node, and set some value or set a data of an existing node, and so on. We can do that in a single shot using multi-update. And here the synchronization is really well done. Okay. All right. Um, Sorry, I missed your question, Laksh. Uh, his point was when the client disconnects, does Zookeeper retains the data of sequential node? Yes. So sequential node is mainly a persistent node. Okay, so to give your answer to your question, I just saw the question. Did I miss? So other than Sravna's question, I hope I have not missed any other question. All right, let me just. Okay. All right. Yes. So Zookeeper is more like a persistent node, you can say. Just that, sorry, the sequential node is more like a persistent node. All right. The API to access Zookeeper are at the heart. There are two core API. One is Java, other is in C. There are these wrappers available as a contribution from various languages such as Perl, Python, Rest. So whatever we did from the command line, like creating this node, checking the node, all of this could be done through the API. And the most interesting part is that there are two kinds of two kinds of functions available for each action. For each action, there are two kind of function, sync and async. And can anybody quickly tell the difference between sync and async? Yeah, synchronous and asynchronous. So the way we can call talk to zookeeper, either we can directly write on the command prompt, or using a program we can connect to the zookeeper and start talking to zookeeper using the API provided. All right. Now these APIs, all of these API has a common thing. Every function, whether exists, create, delete, every function has got two kind of two implementations for it. One implementation is synchronous, and the synchronous means that when we call the function, it makes us wait, and then once it's done, we get the value. So the program flow waits till the function gets completed. Whenever we are making a function call and it's synchronous, it makes us wait. All the functions which we have talked so far had been synchronous. Okay, like for example, here when I'm saying create sequential node, okay, it would it would do the things and then we will move ahead. We are not moving ahead before it has finished the work. So that's a synchronous call. Now the second version of the same function is in asynchronous call. And this asynchronous call returns void, meaning it does not return anything. It's more like it's more like a kind of background job. We tell zookeeper that please do these actions, create this node or update this node, upload this data, whatever. We tell zookeeper that do this, and once you are done, please execute this particular callback function. Okay, so this way we return immediately, and this whatever work we are giving as asynchronous, kind of it happens in the background. Okay, in case you want to do something after this function has finished, you provide that work as part of callback. All right, so callback will be called as soon as this function has finished. All right, there's a question from Lux. Does Zookeeper use Thrift Server for its API? The answer is no. All right, for some reason they are not using Thrift Server as per my knowledge. All right, one more thing you will notice everywhere in these functions, other than path, so exist is equivalent to saying ls slash ls and path name. There is one more thing called watcher. Watcher is an activity which gets triggered as an event. Okay, so let's say you want to watch something on this path. You basically check for exist function and provide a watch, and this watch gets executed at various point of time. It will be executed at a particular event. All right, so these are called watches. So clients clients to get notification when jet node changes in some way, we have watches. Watches are triggered only once. For multiple notifications you will have to re-register. Okay, so what watches of various functions are triggered in this manner. So watches of exist function get executed when the node is created, deleted, or the data of this particular node on which the exists was called, the data gets updated. The watches of get data gets called or triggered when Z node is deleted or has its data updated. Okay. Similarly, watches of get children are triggered when Z node is deleted or it's any of the child is created or deleted. Make sense to you? All right. So now other than Znode, it provided us something called watches, and also it provides us the full control of permissions because Zookeeper would be a central service. Zookeeper will be used by HBase, maybe used by primary name node or secondary name node, or maybe your email processors. So there will be hundreds of services in your organization that use Zookeeper. Therefore, Zookeeper provides you proper access control list. Okay, access control has two parts: authentication and authorization. Can somebody help me with the difference between authentication and authorization quickly? Anyone? All right, Lux says authentication is equal to login, brilliant, and authorization is roles and privileges, brilliant. So whenever we talk about security or access control, there are two parts to it: authentication, which means making sure you are who you claim you are. Okay, and second is authorization, which means checking whether you are trying to access what you are allowed to access. Okay. So you can log into a system, but you may not be able to do everything. You will be only allowed to do only fraction of things. All right, that is authorization. So it provides authentication in three forms: digest, meaning login password; SASL, which is using Kerberos. Kerberos is a single sign-on system, and you can use Kerberos for various authentications. The and IP address. The client is authenticated just by the fact that it has got a particular IP address. Okay, so ACL is first has one part called authentication scheme, and then identity of that scheme, and then permissions. All right. Now let's talk about the most important aspect of Zookeeper. Okay, this is something which I want everybody to pay full attention to. So let's discuss in detail the architecture. Why I'm talking about this? Because this is the most important part of any true distributed system. Okay, in case of name node, our bottleneck was in case of HDFS, our bottleneck was name node, right? And similarly, in case of HBase, our bottleneck is HBase master. In case HBase master is shut down, there is no way we can do anything. All right. So therefore, those systems are not really truly distributed systems in that sense. And that's where Zookeeper kind of architecture should be understood by all of us. So Zookeeper runs in two modes called standalone and replicated. Standalone is just for one machine, replicated on multitude of machines. And this is how it runs in an organization. So in general, if you are a big data company, you would definitely have Zookeeper running on your cluster, either independent cluster or or on the same cluster on which you have installed Hadoop. And this cluster of machine is called ensemble. And the machines which participate in Zookeeper running, which participate in running the Zookeeper are called ensemble. These ensemble basically are for high availability. It tolerates as long as the majority of the nodes are available. Okay, and what does it mean by a majority? 6 is a majority in 10, 3 is a majority in 4, okay? 2 is not a majority in case of 4, meaning more than 50% is a majority. All right, more than 50% is a majority. So if more than 50% of the machines are available in the network, it will keep running happily. If 50% or less than 50% machines are available, then it will become the read-only system. Zookeeper will become the read-only. All right, let's get into the architecture. So when you install the Zookeeper on a cluster of node and you inform them about each other, okay, when you inform them that this is my zoo, these are the other machines available in the ensemble, they start talking to each other. All right, so you install Zookeeper on say 10 machines or maybe 15 machine or whatever you want, and they start, you tell them about each other, and these machines automatically select their leader. Unlike HBase master or name node, where we designated one machine as the master, here the master is designated out of existing nodes. Okay, these all right, out of existing nodes, these out of existing ensemble of machines, one will be selected as leader, rest will be called followers. And as soon as this phase of master selection or leader selection finishes, then majorities will synchronize their state with the leader. If at any point of time leader fails, if leader shuts down or leader is not responding to the client request, leader will have to be stepped down or will be forced to step down from its designation. Okay, and there will be another election and somebody else will be elected as the leader within 200 milliseconds. Sounds exciting to you? All right, so leader selection could happens this way. Now, once the leader has been selected, all the write requests are forwarded to the leader. Write means whenever user wants to write something, the request will be forwarded automatically to the leader, because every member in the ensemble knows who is the current leader. So any other member, if they get a request from the end user for writing some data, creating a Z node, or putting some data in the Z node, or deleting a Z node, these are write requests. If such kind of request for modifying the data are received by anybody other than the leader, it will be forwarded to the leader by the member of the ensemble. Okay, so all the write requests go to the single machine. All right, why? So that the consistency can be maintained. If you have multiple machines receiving the data modification request or write requests, the the data will be useless if you have multiple nodes parallelly modifying the tree. okay, the data will be fairly useless. Therefore, there is always one single node modifying the data. Rest are just providing the ability to read the data. Therefore, the the ability to read the data from any zookeeper is far more higher than writing the data. And which is also true in general behavior. We change data less often than the pace at which we read the data. Now, once a leader receives a change, it broadcasts that particular change, or that it broadcasts that particular update to all the followers. Leader receives the change from the user. It sends that change to all the members of the herd. Okay. Now, as soon as it receives confirmation from more than 50% of the member, when majority says yes, we have saved the data, it tells the client that okay, your data is saved. All right. So the write request could be a bit slow because it waits for 50% members to save. But since this 50% members are trying to save it parallelly, therefore the action is actually pretty fast. So the protocol for achieving the consensus is atomic, like two-phase commit. And machines have to write to the disk before in memory. This is very important. Okay, so any data is persistent. Whenever we get a confirmation from zookeeper, the data is written to the disk. All right. Now let me read out Lux's question. His question is: so the cluster needs minimum of 3 nodes. It can have 2 nodes as well. They can vote for each other, and based on the ping response, one leader will be elected. All right. What is the criteria to select the leader? The criteria to select the leader is generally the response to ping requests. If somebody is responding to the ping request from each other really fast, they will have higher chances of becoming leader. All right, sounds interesting to you? No? All right. Now there is further to it what we have just talked. All right. Let's represent the same thing diagrammatically. There are these three machines right now in this example where there are clients talking to the follower, and there are clients talking to the leader, and so on. So these clients are trying to read. So read can occur from the leader as well. But if a client is trying to write, he gets redirected to the leader. All right. And these all machines have just marked. All machines have given vote to make one of the machines as leader. If this leader fails, somebody else will become the leader. All right. Now, so Sanjay's question is: leader is not selected on power of machine. No, because power of machine is derived, it is useless if it's not able to respond to the ping request really fast. Okay, or any of the operation request, if it's slow, then it's not considered really great. All right. Ravikant's question is, this means that all the nodes will share the same data. Yes, you got it right. All the nodes will have the same data set, which means if you have a configuration of 1 gigabyte size and 100 nodes, it will actually get stored on all 100 nodes. That means it's going to waste 100 gigabyte storage. That's why. And also the same 1 gigabyte of storage and 100 gigabyte of RAM, because same data is also available in the memory. Sounds good? Therefore, we always say that Zookeeper is for keeping very small amount of data, very small amount of signals. All right? Now, there is a very important aspect here. Now, in case one of the follower dies, as I was telling you earlier, that in an ensemble, if if total number of alive machines are less than or equal to 50%, there will be no leader. This is something very strange. This is something very strange and something which will take some time to understand. Okay? If you have 100 machine in the network and 50 are down, there will be no leader. If there is one leader still alive, it will step down. Okay? So the whole system will become it will become read only, absolutely read only. Because there is no leader, therefore nobody is accepting the write request, it's only giving the read request. Alright, if you have 100 machines in the network and 50 are down, there will be no leader and system will be read only. Okay, now can anybody give me a good reason why is it so? Also, if there is no leader and we are trying to do the election, what happens is, if less than 50% votes are available to any leader, less than 50% votes are available to any leader, or less than 50% nodes have participated in election, or less than or equal to 50% of the node have participated in the election, there will be no leader. Such elections are invalid. Can anybody think of the reason why is it so? Although one thing you should note is, in case your cluster becomes read only because 50 machines are down, if if you remove 50 machines from configuration, if you remove dead machines from configuration and of ensemble, okay, such that there are only now 50 machines in ensemble, you are making this change in the configuration. You are telling Zookeeper that okay, fine, we understand that 50 machines are down, let's just remove those dead machines and we restart the cluster with the remaining machine, then the election will go fine. This is very important. Okay, So if you remove dead machines and you accept the fact that 50 machines are down, you remove those dead machines from the configuration and then restart the remaining 50 machines cluster, and ensemble now consists of only 50 machines as part of configuration, not 100 machines. Now it will boot up perfectly fine. It'll boot up normally. Okay. Now, and there will be election. Can anybody give me the reason? I'll answer Alex your question a bit later. You will get your answer, I think. So Sanjay's question is reliability is lost. Okay, good. And why is the reliability lost? Why is what is so special about 50% node? So reliability is anyway lost even if say 20% nodes are lost. All right, but it's a good answer. It's a good answer. You will understand when I describe in detail. All right. Ravikant is saying the availability of data reduces if majority of good, good, but still, don't you think it's very unfair that we have 50 machines still available out of total 100 machines? Still, we should have a leader, right? We should have the ability to write the data. 50 machines are not less data, less machines. Why exactly on 50? 50 or less. All right. It took me some time to figure it out. Okay. And when we were working on MongoDB at the time, we figured it out. Why is it so? All right. Now this is a part of Paxos algorithm. All right. This is a part of way of Paxos algorithm. So there is one person from Microsoft. I think his name is Paxo or something. So he has designed a way for truly democratic way of distributed selection. So he has done a very good, remarkable work. And most of the such system where there is no manual intervention for selection of the leader, most of these systems follow the Paxos algorithm. Now imagine this. Okay, we'll go step by step. Imagine this. We had these three machines A, B, and C, and A is the leader, and A is dead. So what would happen? What would happen? Will anybody become the leader? Anyone? Is 2 a majority out of 3? 3's half is 1.5 and 2 is more than 1.5. So 2 is basically majority in case of 3, 3, right? So still you will have, will somebody become the leader? Luck says no. Anybody else? Quickly. There were three machines in an ensemble. One of them was leader, and the leader is dead. So, do you think somebody will become the leader at this point? No, actually, there will be a leader selection because 2 is greater than 50%. 50% of 3 is 1.5, and 2 is greater than 1.5. Therefore, there will be a leader selection. So, either B or C would become the leader. Alright? Lloyd and Lux? No? Not convinced? Alright, going ahead. Now, next question is what happens in this scenario? Now, In first step, our A server A was stopped. So C became the leader. Now out of B and C, now B is dead. Okay, B is dead. So will C remain the leader or will C step down? Anybody? Will will C remain the leader or will C step down? Correct. Thank you, Ravikant. Yes. So the leader will step down because there is a minority. Because one is less than 50% of three, right? Therefore, there is a minority, and whenever leader notices that there is a minority, leader steps down. Okay, and so neither there will be any election nor there will be any leader. But C will keep on giving the data to the end user in read-only format. All right. So no one will become the leader. No one will become the leader because there is no majority left. All right. There is no majority left. Okay. Moving ahead. Why this concept of majority? You might ask, why is majority so important? Why are we so hung up upon more than 50%? We have 100 nodes. If 50% are down, 50% are still available, right? It should keep on working. Why does a leader need to step down when 50 nodes are dead? Why is it such a big concern? So let me try to explain it, okay? Is the problem statement clear to everyone? Why why C had to step down at this point when a majority is not there anymore? Why did C have to step down from the leadership? So that's the problem statement. The reason is, let's imagine a situation. Let's assume that there is no majority kind of constraint. Okay? And in such a scenario, let's say there are two data centers, data center 1 and data center 2. Think about real data center. Think about a data center located on two different data center which has two partition, one in India, other is in US. They're connected via the wire. It has got 6 nodes in total. And out of 6 nodes, what was the majority? It's ideally it should tolerate as long as there is four or more in a, participating in election. But let's see what happens. So there are ABC on one data center and DEF on another. Out of data center 1, leader A is the leader. Okay, A is the leader at this point. Now think what happens. Next is the connectivity between these two data center is disrupted. Okay, these two data centers have got disrupted connectivity, as in the connection has been cut between the two data center. Now think about the scenario when majority is not a constraint. So what will happen? A will continue to be the leader, and in the data center 2, when they notice that there is no leader, they'll make somebody as the leader. All right, now look at this situation. In both the data centers, we have got two leader, one leader in first data center, other in second data center. Why? Because there was no majority constraint. We did not implement the majority constraint in this case. And therefore we ended up with two leaders. Both leaders are accepting the change or modification requests, deletion, updation, or creation requests, and in the end, the data is absolutely haywire. We'll have two different versions of the data in the two data centers which are non-mergeable. Make sense to you now? So effectively, the majority ensures that there is only one leader, no matter how the network get partitioned. So this is called partitioning of the network. Disconnection between the two data centers is partitioning of the network. So no matter how you cut the cake, okay, I will get the biggest piece if it is bigger than 50%. Okay, let's say it's my birthday and I am one of those kids who throw a lot of tantrums, and I say that I should always get the biggest piece because it's my birthday. Now the only way I can get the biggest piece is by measuring that I get bigger than 50%. Okay, if i'm getting if I'm getting only the 50%, that means if I get only the 50%, then there must be some other guy having exactly equal to me, and my criteria of having the biggest piece is not fulfilled. Out of all the crowd who came to my birthday party, if I have to ensure that I have the biggest piece available to me, the only way I can ensure is by saying that I should get more than 50% of the cake. All right, irrespective of how many people come to my party, irrespective of whether nobody came to the party, I will still get the biggest piece of cake. If I say that I want bigger than half. All right, so there could be only one such partition in the network which is bigger than 50%. There cannot be two partitions in a network which are bigger than 50%. Therefore, there will be only one such leader in a network. No matter how you cut the network, no matter how you distribute a piece of cake, how you divide the cake, how you cut the cake, there will be only one such partition of the cake which is biggest, okay, which is bigger than 50%. There'll be only one biggest one. Similarly, in a network, no matter how the network get partitioned, I mean, no matter how many cables are burnt or cables are disconnected, there will be only one partition in the network which has which is bigger than 50%. There will be only one such partition. Therefore, to ensure that there is always only one leader, this constraint is imposed. Okay, Sanjay, you want me to repeat again now? All right. So let's say what disaster would happen if we did not have this constraint that we need more than 50% in an ensemble. We need more than 50% machines alive in an ensemble. What disaster could happen? I'm going back to the example. So we have, let's say, two data center 1 and 2. Data center 1 has A, B, and C, and there is A is the leader, and D, E, F in another data center do not have a leader. Now, imagine that the connectivity between the two data centers is down. Now, D, E, and F talk to each other and realize that they don't have a leader. So they announce an election, and they also elect somebody. All right? So now there are two leaders. Two leaders accepting the request from the end users and changing the data, altering the data, and therefore there is a utter chaos. Was I able to explain this time? All right. Therefore, this constraint that in an election more than 50% should participate, only then there will be a leader. Okay. Otherwise, there is this fear that this kind of situation could happen. Right? Lux, did I make sense? Ravikant, Sanjay, Sarvana, Lloyd, Mike, Josie, Richard, Anandita, yeah, Kanaga, Jairam, Sandeep. Okay. Mm, all right. So yeah, Lux is saying that we used to have two master nodes in JBoss cluster. To me, it sounds funny because having two master node is basically is a crazy situation. Now again, um, yeah, there is a question from Sanjay. In the case where 50% were dead and 50% alive, we halted entire. We halted. We halted the modification of data. Okay, election of the leader. All right. All right. Anybody? An ensemble of 10 nodes can tolerate the shutdown of how many nodes? Yes, that's correct, Lloyd. So the idea, uh, okay, Lloyd is saying that this is very similar to MongoDB. Yes, very right. This is actually the whole idea of Paxos is implemented by almost everybody where there is a automatic selection of leader or the master happens. All right, so everybody is agreeing on 4. Brilliant. All right, moving ahead. There are few guarantees which Zookeeper provides you. One is consistency, second is atomicity, third is a single system image, fourth is durability, as in whenever we make a change, it is persisted onto the disk. Timeliness, rather than allowing a client to see the very stale data, a server will shut down. If server realizes that there has not been any change for very long time and it has not received any change from the network for very long time, that means there's something seriously wrong. There is some weird network partition has happened and this particular node has been left alone. Therefore, in such scenarios, the node will choose to shut down. It's more like a suicide. All right. Now, the Zookeeper server provides you something called sessions. This is important with respect to the client library. So every client who connects to the Zookeeper maintains a list of servers in the ensemble. All right, sounds very strange, but that's how it is. So when any client is connecting to the Zookeeper, If you give it one particular only one machine, the client library will gather the details about all the machines in this ensemble. And since it has list of all the servers in the ensemble, the client will keep on trying from one end till another until it is successful or it has exhausted the full list of servers. Okay, so it keeps on trying to connect, and the server every time every time it's successful, server creates a new session for the client. So there is a session on the server side as well. So zookeeper, what do you call zookeeper, master or follower, a leader or follower, both are considered as server at this point of time. So the server creates a new session, and this session data is synchronized with other nodes in the network instantaneously. And once the session is created, it has got a time period which is decided by the client. So if I'm connecting to Zookeeper, I can say that keep my session alive for 2 hours or one day. Okay. If the server has not received a request within this timeout period, which the caller himself declared, okay, the session is expired. If the section, just like the banking website, if you don't do some activity for some time, your session gets expired. On the session expire, all the ephemeral nodes created for that session, created by that session, disappear. One user can create multiple sessions. All right. If you have as the session expire, the ephemeral nodes created during that session will disappear. And to keep the sessions alive, client keeps on sending the pings called heartbeats. Okay, so the client who is connected to the server will keep on sending to the zookeeper machines continuous pings so that the server assumes that the client is there. If it does not receive the any pings for more than timeout, then it will time it out. Okay, just like when you are using a bank website, you keep on either clicking here or there just to send a ping to the server that okay, you are on their website. So similarly, the client also keeps on sending the heartbeat in order to keep their server session alive. Now, do not worry, if you are talking to Zookeeper, you do not have to implement all of this. Okay, almost everything is taken care by the client library provided by Zookeeper. Client library takes care of all of this, trying to iterate over the full list of servers, trying to creates the session, creates the timeout, and also keeps on trying if the connection is lost, also keeps on sending the pings. Okay, so similarly failover is also handled by the client very nicely because client has got the full list of servers. So if the connection is lost by server 1, it will keep on trying another servers. All right, if the Zookeeper machine goes down and the client shifts to another machine, the client connects to another server, the session will switch to another server. And but in during this case, when it's switching to another server, it won't be able to do anything at this point of time. When it's in the limbo, it's not connected, the client is not connected to any of the server, it has disconnected from the previous server, it's trying to connect new server because the previous server was dead. In this mid time, if you try to access something, it will give an error, and therefore your application who is using this application library cannot remain agnostic of the failures because it has to handle the circumstance where there is no machine available. So Sanjay is saying, can a cluster switch from read to write and vice versa? Do you mean to say, can a leader switch to from read to write? I did not get this question. Could you repeat, please? All right. The session, the way it's created is the client says new zookeeper and it tries to connect, and the moment it gets connected, a event is received on the client head and saying that yes, the connection has been established, and so on. All right. No, we don't have to restart. Okay. So we don't have to restart for the election. Only in the cases if you got the minority and your 50 machines are dead and you want to run your ensemble with remaining 50 machine, only in those cases you will have to update the configuration and restart, in only in those cases where due to minority the system has become read only, and you want to fix it. All right. Now, as I was telling you, the zookeeper will be used by many people in the organization. So you can imagine the situation like this. Okay. Sorry. So this is basically a use case of zookeeper. We'll talk about the rest maybe later. So yeah. So let's say you have these many servers. Okay, these many servers available on one end, and then there are these many clients who are trying to connect to these servers, and assuming any server could be down or up at any moment of time. So how will the client know how many of these servers are currently down at this very moment? For that they use zookeeper. Okay, these servers give their attendance to zookeeper by the way of creating ephemeral nodes. Okay, an ephemeral node will remain active as long as the connection between each of these servers is alive. As soon as the connection is broken, those ephemeral nodes will disappear and that particular node will not be uh, discoverable to the end user. All right. All right, I think this will give you a better idea. Let's say one server has been added into the network, or region server has been added to the network. As soon as it's connected, it gives an information to the central node, zookeeper, saying I'm up. So here is it is creating an ephemeral node to give its attendance. So this machine is giving creating two ephemeral nodes, duck and cow, representing its presence. Now, at this moment at this moment when duck and cow has been created, okay. Now, all right. I think I'm not clear. All right. Thank you for letting me know. Let me repeat it from the beginning. Let's say let's say what happens in these scenarios. One server came. I think I should have just changed their look and feel. Uh, can I change the look and feel? Yeah, I'll just change, I think, line color to red. All right. So there are two machines. Uh, so first is the machine talks to zookeeper and connection is established. After both the machines have created the connection, what they do is the machine one creates its ephemeral node called duck with its name, and then second machine called cow creates its ephemeral node. And at this point, if you say ls/server, you will see both duck and cow, right? Now, after this point, if duck is killed, this particular machine, this machine goes down, and then after around 5 seconds, if the somebody says ls/server, you will only see cow. All right, I'll show you that. So, did we create any? All right. So there is this my EPH node. Do you see the my EPH node? If I disconnect, right now I disconnected myself from here. And if I connect again after some time, let's say after 5 seconds, after 5 seconds, this node, my EPH, will disappear automatically. All right. You can see that my EPH has now disappeared automatically because it was an ephemeral node and the client who created it that has disconnected now because I closed this shell and started again. All right. So this is how ephemeral node works. So I've gone through this particular aspect of creating nodes. You can also go through this creation of node. There are many other use cases such as reliable configuration service, distributed log service, and at the same time, if you are creating a distributed log service, only single process may hold the log. So, okay. So when not to use Zookeeper, that is an important aspect. When not to use a Zookeeper is when number of copies, when the data is bigger. If you are trying to store, say, 50 gigabytes of data, then Zookeeper is not really your choice. You should be storing only very small data because it consumes equal amount of RAM on all the nodes equal to the actual data size, as well as it consumes the disk space on all the nodes parallelly equal amount of disk space. Although the consistency is really great because it is on more than 50%, but if you need strong consistency, as in all the nodes at the same time having the latest data, then do not use Zookeeper. But probably out of most of the NoSQL, Zookeeper has got great consistency and great availability. All right, makes sense to you now? Any questions at this point of time? No questions? All right. Please do this assignment. Please create your own node and try to create all three kinds of node, ephemeral and all of these three nodes, and then try disconnecting and connecting again. Sure, sure, Lux. Okay. All right, all right, great. So we will start with the Flume and other things, Scoop, Flume, Uzi, Mahat on the next week. All right. So I'm hoping that the on the next weekend we will complete the course. All right. All right then. Have a great day. Bye bye. Good night. And Sarvna, could you please copy your questions? I missed those questions, and just send me those in email. All right. Thank you very much. Have a great week ahead. Bye bye. All right. Thank you, Joshi. Thank you, Kanaga. Bye, Lloyd. Bye, Lux. Bye, Sanjay. Bye, Sarvana. Bye, Ravikant. Bye, Sandeep. Bye. All right. Okay. I'll just wait for 2 minutes also because there's a question from Savna. I'll just finish it now. All right. His question is related to the pig. All right. So first question was, how does filter works in pig? Basically, filter results in a map task. Okay, that's how the filter works. Second is, if I want to use UDF in filter, okay, okay, you can do that, yes. So you can say that filter by my function act on some tuple equals to x. So it doesn't necessarily mean that your function has to return boolean. It can return anything. Say you are writing something like this. Okay, this function is coming from UDF. It doesn't need to be boolean. All right. All right then. Bye bye, Savna. Try doing it. If you get stuck, drop me an email. All right. Bye bye. Have a great week ahead.